Hey guys, can y'all hear me? See, there's a few people here. Yes, nice. Does it sound clear, Jasmine? Okay. If y'all hear my dog start barking in a second, it's because my son's going to be home and just giving you a forewarning because he barks really loud. So, all right. Well, so what I was going to do is my plan is to go over the study guide. And then if you have any questions, I want you to ask questions. And then if I have any time at the end, I can take questions and just do extra problems of any topic, but ask questions as I'm going. You don't have to wait for me to stop and ask questions, okay? All right, so let's just get started. And so this will be recorded too. So if you wanted to go back and, rewatch something or fast forward or whatever, you can do that. All right, so looking at the first question. All right, so I'm going to go ahead and graph these, and these are both already in slope-intercept form. And so the top one, the y-intercept is +1, so I'm going to start off at +1. And then the slope is -1/2, which is -1/2 or 1/-2. That doesn't look like a -2, does it? Okay, so from the y-intercept, I can go down 1 to the right 2, down 1 to the right 2, or I can go up 1 to the left 2, up 1 to the left 2. And then I'm going to connect my dots. And then I'm going to do the same thing with the bottom equation. I'm going to graph this one in blue. So the y-intercept is -4. And the slope is also -1/2. So I go down 1 to the right 2, or I go up 1 to the left 2, up 1 to the left 2. So when I graph these, I notice that they will never cross or touch, which means that there is no solution, because the solution on a system of equations, the graph, is where they cross or touch. So these, because they're parallel, they won't cross or touch. Now, I also knew this was going to happen before I even graphed, because I saw that they have the same slope and they have different y-intercepts. So because they're starting at different places here, but they're changing at the same rate, they're never going to cross or touch. So I knew that they were going to be parallel. All right, the next example, same thing. I've got my y-intercept here of -2. So I'm going to start off at -2. The slope is +1/2. So I can go up 1 to the right 2, up 1 to the right 2, or I can go down 1 to the left 2, because -1/-2 is also equal to 1/2. So I can go down 1 to the left 2, down 1 to the left 2. So I'm going to connect my dots, and there's my line. So the next one, I'm going to graph in red. So I'm going to start at -4, and my slope is 3/2. So I can go up 3 to the right 2. And I didn't even have to go the other way, but just to point out, that would be the same as going down 3 to the left 2, because a negative over a negative is positive, but I didn't have enough room to do that anyway. And so here I can see that these two graphs intersect right here, which is the point 2, -1. So that is the one solution that they share in common. So that's the solution to the system. All right, I see no questions, so I will keep going. See, I told you he was going to bark. Hold on 1 second. Let me shut my door. There we go. Okay. All right, number 3. All right, so this one, the challenge with this one, and I think this is where there's some confusion, is that you have to rewrite these in slope-intercept form, okay? So I'm going to start with this one right here. So I have x minus y equals 3. And I have to write it like the first two problems that we were doing. So they need to look like y equals mx plus b so that we can graph them. So I'm going to start off by subtracting x from both sides. So I am left with -y equals 3 minus x. But notice how we have the mx first and the b last, like the y-intercept is last, the constant. So I'm going to swap the order, but when you swap the order, the sign before it goes with it. So this is going to be -y equals -x plus 3. So I'm going to divide both sides by -1. And when I do that, this gets divided by -1, and this gets divided by -1. So y is equal to positive x minus 3. Because a negative over a negative is positive, and then a positive over a negative is negative, okay? So when I graph this, and I guess I'll go ahead and graph this in blue. So my y-intercept is -3, and the slope is +1, which is 1 over 1 or -1 over -1. So from here, I can go up 1 over 1, over and over again, or I can go down 1 to the left 1. And this is what that one looks like. Okay. So then, I'm running out of room, do this to myself. All right, so let's do this one down here. All right, so we have 8x minus y equals -4. So I will subtract 8x from both sides. Now, notice I am left with -y. When all that cancels out, I have -y left, not just y. So be very careful about that. That's going to make a big difference. And that's equal to -4 minus 8x. Now, I'm going to go ahead and swap the order again so that I have this x first that I was talking about. So when I do that, that gives me -y equals -8x minus 4. But I want to get rid of the negative because I don't want it to be -y, I just want it to be y. So I'm going to divide by -1, and I'm going to divide by -1 on both sides. So this gets divided by -1, and this gets divided by -1. Let me move this a little bit. Okay, so that all canceled out, leaving me with y equals a negative over a negative is positive. So this is 8x, and a negative over a negative is positive, so plus 4. So I have y equals 8x plus 4. So I'm going to graph this one by starting off at +4. Now here, my slope is 8 over 1, but I don't have enough room to go up 8 into the right one. So I'm going to have to go the other direction. And so the other direction is to do -8 over -1. So, sorry. Sorry, I'm still here. Okay. So from here, I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and to the left 1. So it's important that you know how to go both directions, just in case you can't, there's not enough room on the graph, such as this example right here. So you can see that this is my beautiful drawing, but this is where those 2 points intersected. They were supposed to intersect anyway. So that is the point -1, -4. I guess nobody has questions yet, so I'll just keep going. Remember, those of you watching the recording, you can pause if you need to go back or rewind, you have that luxury. Okay, so this one, I'm going to do the same thing. Neither one of these are written in slope-intercept form, so I'm going to do that. All right, so this one here, so we have 2x plus y equals 3. I'm going to subtract 2x from both sides. So I have y equals 3 minus 2x. But again, I want to swap the order because I want the slope first. So this is -2x plus 3. And so now when I graph it, it's already in slope-intercept form. So I'm going to start off at +3. And the slope is -2, which is -2 over 1 or 2 over -1. Both of these are equal to -2. This is just 2 different ways of writing it. So from here, I can go down 2 to the right one, down 2 to the right one, or I can go up 2 to the left one. And that's a crooked line, sorry, but you get the idea. All right, so then let's do this one right here. So we have 2x plus 3y equals -3. I'm going to subtract 2x from both sides. That cancels out. So I have 3y equals -3 minus 2x. Again, I'm going to swap the order. So I have 3y equals -2x minus 3. Then I'm going to divide both sides by 3. This gets divided by 3, and this gets divided by 3. So I have y equals -2/3 x, and then -3 over +3, because this is a +3. So -3 over +3 is -1. So this is the equation I'm going to graph. So I'm going to start at -1. And a slope of -2/3 is -2/3 or 2 over -3, just like we were doing here. The negative has to be on the top or bottom. It can't be on both. Okay, so from here, I'm going to go down to the right 3, and I see that they intersect right there. And so there is the answer, which is 3, -3. Okay, so remember on your test tomorrow, if it says to solve by graphing, you have to solve by graphing to get credit. You can't do substitution and then plot the point. Okay, you need to actually plot the lines. I need to see all this work right here that shows that you're writing it in slope-intercept form and all that, okay? All right, let's move on to number 5. So number 5 started with substitution. So the idea with substitution is you take one equation and substitute it into the other, but it has to be x equals or y equals before you can substitute it. So I'm going to start with the top, and since the top one is y equals, I can replace the y. So I'm going to take the first one and substitute it into the second one. So this gives me 2x minus 6 equals 7x minus 21. And then I'm just going to go through the process of solving it. You don't have to do this the exact same way, meaning you don't have to start off by adding 6. Subtract 7. You have a couple of options here, but this is what I'm going to do first. So I'm going to add 6 to both sides. So that gives me 2x equals 7x minus 15. And then I'm going to subtract 7x from both sides. Running out of room. So that gives me -5x equals -15. And then I'm going to divide both sides by -5 so that I get that x is equal to +3. Because remember, this was a -15 here that you brought down, not a positive, okay? So to figure out what y is, I can use either one of these original equations. It doesn't matter which one. I'm just going to use the top one. So y is equal to 2 times 3 minus 6. You are substituting 3 in place of x, the x that was here. There is no more x when you put the 3 in it. I've noticed a couple of people are keeping that x still there, and you want to make sure that that you're totally replacing that x, okay? So that means that y is equal to 6 minus 6, so therefore y is equal to 0. So you want to write this as a coordinate point, which would be 3, 0. Okay, looking at number 6, I still don't see questions. Okay, so this one, again, we want to take one of the equations and substitute it into the other. But neither one of them are x equals or y equals, so we're going to have to fix that. So I noticed that in this equation here, that the y has a coefficient of 1, which means I'm not going to have to deal with fractions because I'm not going to have to divide by anything in the end. So I'm going to pick that equation to write. So if I take, I'm going to move this over here. Okay, so if I take this equation here, if I have 5x plus y equals 7, and I want to write it as y equals, I want to get the y by itself. So I am going to subtract 5x from both sides. This gives me y equals 7 minus 5x. So now I can take this, which is y, and since I rewrote this equation, I have to plug it into the top one. So again, I rewrote the bottom equation so that I can plug it in or substitute it into the top equation. All right. So when I do that, my top equation becomes negative 4x minus 2 times 7 minus 5x is equal to 4. Again, notice the y was here before, right? But I am substituting it in. There is no more y because the whole point is that you only have one variable. I have two x's here, but I have one variable. X is the only variable that's in here. Because if I have two variables, I can't solve for them. But by substituting, I've gotten it down to where there's one variable in the problem. So I can figure out what x is this way. All right, so I am going to distribute negative 2. So this becomes negative 4x. Negative 2 times 7 is negative 14. Notice that negative 2 is gone. And then negative 2 times negative 5x is positive 10x. And then that is equal to 4. So now I'm going to combine like terms. I have negative 4x and positive 10x, which is positive 6x, minus 14 is equal to 4. I'm going to add 14 to both sides because I want to get the constants. I want to have the constant on the right and the variable on the left. So this cancels out, leaving me with 6x equals 18. And I'm going to divide both sides by 6 so that I get that x is equal to 3. Okay, so we have that the x part of the vertex is 3. So to find the y part, you can use either one of the original equations. We can even use this one here that we rewrote, which I'm going to tell you is going to be the easier one to use because see how it's already y equals, and that's what we're trying to figure out. So that's the one that's going to be easier for us to use. So we're going to use that one. So we're going to say y equals 7 minus 5 times 3. Y equals 7 minus 15. Y equals negative 8. So you should have 3 comma negative 8. Questions so far? Don't see any. All right, number 7. So again, we have another substitution problem, and I'm going to come over here just so I have room. Okay. So when I look at my choices, I either need to rewrite this equation as x equals or y equals, or I need to rewrite this equation as x equals or y equals. This one is going to be the easiest because the y has a coefficient of 1, which means I am not going to have to divide and have any fractions, okay? So I am going to do that over here. So I have 3x plus y equals negative 6. So I'm going to subtract 3x from both sides, which gives me y equals negative 6 minus 3x. Now, if you want to swap this so that it's in slope-intercept form, you can, but you don't have to because you're substituting it back in. The whole point of the slope-intercept form is for graphing purposes, but since we're not graphing, it's okay. You don't have to do that, okay? So I'm going to take this that is y, because again, we rewrote this one to substitute it into the second one. So I'm going to substitute negative 6 minus 3x into the second equation. So when I do that, that gives me 7x plus 4 times negative 6 minus 3x is equal to negative 9. Okay, so I will also say this too. I noticed a lot, like when you guys have been doing Delta Math the last couple of days and I've been walking around the room, a lot of issues have happened just with negative signs. Like make sure this says negative 9, make sure you get negative 9 here. if when you're doing your test or quiz tomorrow and you get an answer, or your test tomorrow, when you're doing your test tomorrow and it doesn't make sense, the answer that you get, go back and double check and make sure you wrote everything correctly. Honestly, half the time that's the issue. It's just that it hasn't been written down correctly. Like the numbers haven't been transferred right. So just go back and double check and make sure of that, okay? Because sometimes I do the same thing. Y'all have caught me doing it. We just go so fast, we make those careless mistakes. So just go back and double check and make sure you're writing it correctly, okay? So with that being said, so we have replaced this y here with all of this here, okay? Now we have to distribute. So we're going to distribute this 4 to both terms on the inside. So the 7x, nothing gets distributed there, but 4 times -6 is -24. 4 times -3x is -12x. And then I'm left with -9. Okay, so I'm going to combine like terms. I have a positive 7x, and I have -12x, which is -5x, minus 24 equals -9. I feel like I'm doing something wrong here. Oh, no, I'm not. Okay, so then I'm going to add 24 to both sides. So I have -5x equals 15. And when I divide both sides by -5, I get x equals -3. So again, I need to find the y now. So I know my x is -3, but I want to find the y. I could use either of my original equations, but see how this one here that we rewrote is already y equals? So I'm going to use that one. So this gives me y equals -6 minus 3 times -3. You have to follow the order of operations, okay? So -3 times -3 is +9. So this is -6 plus 9, which is 3. So you're going to have y equals 3. So the answer to this one is -3, 3. All right, so now we have number 8. I still don't see questions. Okay. So this one, again, we're doing substitution, but we have a little gift here. One of them is already written as y equals, so we can take that and substitute it in for y right here. So when we do that, so we're taking this and substituting it into this one, okay? So this gives us -4x minus 2 times -2x minus 1 is equal to 2. So again, I've just replaced all of this, which was y before, but I replaced it with that top equation. So I am going to distribute this -2 so that I have -4x plus 4x plus 2 equals 2. Because -2 times -2x is 4x, and then -2 times -1 is +2. Now, when I combine like terms, I notice that I have this -4x and +4x here, which combine, or they cancel out. -4x plus 4x cancels out. So you are left with nothing, not even an x. Okay, so that's all 0. Plus 2 is simply 2, so we have 2 equals 2. 2 equals 2 is a true statement, which means infinite solutions. So all solutions that are on each of those lines would work. Okay, so no questions about substitution. Moving on. Okay, all right, so now with number 9. Number 9 is about elimination. So with elimination, the idea is that you eliminate a variable. You either get rid of the x or you get rid of the y. And so you can multiply, if I multiply this bottom by -6, that's going to give me this +12y here, because you want to pick something to where you can eliminate a variable. So if I have -12y and +12y, my y's would cancel out. So that's the whole point of the elimination process, is that you're getting rid of a variable. So again, you're only dealing with one variable, kind of like with substitution. You're only dealing with one variable there. All right, so I'm going to multiply the whole bottom by -6. So the top is -7x minus 12y equals -14. And then the bottom is 30x, because again, I have to multiply this by all three terms, okay? So you have 30x and then plus 12y equals positive 60. So I'm going to add them together. The y's cancel out. So I have -7x plus 30x, which is 23x. It says I only have 10 more minutes to hurry. Okay, 23x and then -14 plus 60, which is 46. So I'm going to divide both sides by 23. So I'm going to get that x is equal to 2. So if x is equal to 2, you have to plug back in to figure out the y. And you can plug it back into either equation. It doesn't matter. So I'm going to do the top one. Yes. So the -14, positive 14 cancels out. So I have -12y equals 0. And that's okay. You can divide by -12 and you get that y is equal to 0. I'm going to start talking a little bit faster. The program I'm using only has a 40-minute limit, and so it just said I only have 20 more minutes. So I'm going to kind of talk a little bit fast, and I'm sorry if I'm going too fast for y'all. I have 10 minutes to do 8 problems. So here, what did you do? All right, so number 10, elimination. I'm going to multiply the top by -4, and I'm going to do that so that I can get the -8y. So the top equation becomes -28x minus 8y equals -32. And the bottom stays the same at 10x plus 8y equals -4. The y's cancel out. So I have -18x equals -36. And when I divide both sides by -18, I get that x is equal to 2. So now to figure out the y's, you could use any of the equations. I'm just going to use this top one here. So 7 times 2 plus 2y equals 8. So I subtract 14 from both sides, and I'm getting a little bit messy here. So I'm going to have 2y equals -6. So you end up with y equals -3. So the answer is 2, -3. All right, 11, we're still doing elimination. So I'm going to multiply the bottom by -3. And I'm picking -3 because that'll give me the positive 6x to eliminate the x's. So the top equation is -6x plus 7y equals 14. But the bottom equation becomes positive 6x minus 24y equals positive 54. So I'm going to add my x's together, or eliminate my x's, I'm sorry, and add everything else I have together. 7y minus 24y is -17y. And then 14 plus 54 is 68. When you divide by -16, you get that y is -4. Again, you could use either of the equations. I'm just going to pick the bottom one. So -2 times -4. Notice I'm not leaving the x there. I'm sorry, I went the wrong one, didn't I? I'm substituting for the y, not the x. So -2x plus 8 times -4 equals -18. Oops. Add 32 to both sides. So -2x equals 14. And when I divide by -2, I get that x is -7. So the answer here is -7, -4. Okay. Number 12. We have a couple of options here. I'm going to multiply the top by -3. So that way I'd have the x's cancel out. So you're going to end up with 3x minus 12y equals positive 24. And then the bottom is 3x plus 12y equals -24. So here you're going to notice the x's cancel out, the y's cancel out, and even the constants on the right cancel out. So this means we have 0 is equal to 0, which is infinite solutions. Okay. All right, now here for 13 and 14, you can use whichever method you would prefer. 13, because of the way it's set up, standard form over standard form, it lends itself towards elimination. So I'm going to multiply the bottom by -2. So the top is -16x minus 20y equals -2, and then positive 16x on the bottom plus 20y equals positive 12. So here the x's cancel out and the y's cancel out, leaving me with 0 on the left, nothing on the left. But on the right, I have -2 plus 12, which is equal to 10. So this is a no solution. Okay, so this is no solution because this statement is not true. This one was infinite solutions because that statement was true. So that's the difference between infinite and no solution. On number 14, you could pick whichever method you want. I'm going to go ahead and multiply the top by 2. So this is 2x plus 8y equals 10. Then the bottom stays the same at -2x plus 3y equals 1. So my x's cancel out. I'm going to add everything I have together, which gives me 11y equals 11. Divide both sides by 11, and y is equal to 1. Again, pick whichever equation you want. You can pick the 2 original or even the one that you changed. It doesn't matter which one. I'm going to pick the top one. So x plus 4 times 1 equals 5. And you end up with x equals 1. So our answer here is 1, 1. Okay. For these last ones, just because I don't have enough time, I'm going to show you how to set them up, but I'm not going to go through the process of solving them, okay? The key is online, so you can see the work on how to solve it, okay? So this question, you have senior classes, they're going on a trip. So I'm going to say that X is going to be represented by vans, or the vans is going to be represented by X, and the buses is going to be represented by Y. So I notice I've got 2 equations here, okay? A rented 14 vans and 10 buses with 326 students. So A rented 14 vans and 10 buses for a total of 326 students. But then B filled 7 vans and 13 buses with 323 students. Does it matter, Micaiah, are you talking about which method you choose? If it doesn't tell you which method, you could use whatever method you want. And in most word problems, it doesn't matter which method you choose. So B, 7 vans and 13 buses is 323 students. So for this one, yes, you will get the same answer regardless of which method you use. This one, like for this van problem, I would probably end up using elimination just because of the way it's set up, but you could make that elimination and be a little bit, I mean, substitution be a little bit tougher, but you could. So 16, so we have tickets to the dance. So I'm going to say that X is senior citizen tickets, and I'm going to say that Y is child tickets. So 14 senior citizen tickets and 5 child tickets sold for a total of 109. So we're going to say 14x plus 5y equals 109. And then the school took in $47 by selling 7 senior citizen tickets and 1 child tickets. So 7 senior citizen, 1 child for a total of $47. So again, you could use whatever method you wanted on this one. You could use substitution or elimination on this one because of the 1 in front of the y right here. That'd be easy to do substitution. 17. So the sum of 2 numbers is 75. So we're just going to say that x is the first number, and we're going to say that y is the second number. Okay. So the sum of 2 numbers is 75. X plus y equals 75. And then The second number is 3 less than twice the first. Okay, so the second number, and actually I'm going to break this up. The second number, that's y, means equal. 3 less than, that means minus 3. 3 less than something means you're taking away 3. Twice the first. So twice the first is 2x. However, whenever you see less than, greater than, more than, that tells you you have to swap the order here. So really, this equation is going to be y equals 2x minus 3.